Hi you guys, today we're going to talk about Chapter 7, Section 4. These are only going to be about special parallelograms. In Chapter 7, Section 2, we talked about the different theorems of parallelograms. In 7.3, we set out how do we prove different quadrilaterals are parallelograms. And 7.4 now is just going to be special parallelograms. I'm going to write down real quick just the basic words. What are all the theorems that are true for all parallelograms? Then we're going to go to a special elite group of parallelograms. We have rectangles and a rhombus. A rectangle rhombus get together and they make a square. This is the most special, most elite. Okay, first thing we have, both pairs, opposite sides. This is a real quick review, are parallel. That's our first one. Then we got both pair, opposite sides are congruent. We also have both pair, opposite angles congruent. We have diagonals bisect each other. And we have the fifth one, consecutive angles are supplementary. Okay? That's everything that we talked about pretty much in 1 and 2. Now, when we go to a rectangle, all of these 5 theorems are true. So the 5 theorems are true. Okay, again, this is a rectangle. Okay, the 5 theorems are true, plus we add the definition, which is we have right angles, and then we're going to talk about the diagonals. Okay, we have a rhombus. The 5 theorems are true. Okay, so all these 5 are true here, but rhombus also adds its own special characteristics. And again, this one will be about diagonals. Now these two get together, they make a square. And squares will have all the traits of the rhombus. It will have all the traits of a rectangle. And these 5 theorems will be true. So you're going to have the 5 theorems are going to be true. The rhombus theorems will be true. And the rectangle theorems will be true. Okay, let's start out and see what we got. A rhombus. A rhombus is a parallelogram with all sides congruent. If you don't like congruent, put the length of all the sides are equal. That's it. That's what a rhombus is. Now, the cool part of a rhombus, unlike other, I'm going to draw one on here. Okay. If I have a real squishy parallelogram, that's obviously not a rhombus, and I draw these diagonals, you are going to see easily the diagonals are not perpendicular to each other. But if it's a rhombus and all 4 sides are congruent, that's what a rhombus means, these perpendiculars, these diagonals will always be perpendicular. Always. So this one's a right angle. They're all going to be right angles. We only have to put it at one of the angle of the intersection, but all 4 will be right angles. Okay? So for all rhombuses, if a parallelogram is a rhombus, then the diagonals are perpendicular. Okay? Again, it's not true for any other pair, like just say a regular parallelogram that's not a rhombus, it's not true. It's only true for parallelograms that are rhombuses. Okay? The other thing that's cool is if you look at this picture, you're going to see, we know that opposite angles are congruent. Okay, we already know that. This whole angle equals this whole angle. The other part that's true is that we're dividing the angle into two congruent angles. We're bisecting the opposite angles. Again, that's only true if the parallelogram is a rhombus. Okay? So we could see this right here. We're dividing the angle into two congruent angles. Okay? So if a parallelogram is a rhombus, then the diagonals bisect opposite angles. When you look at these, it's all about congruent. Triangles is Y, okay? If you look at this, you can see this top triangle here is going to be congruent to this bottom triangle here. You've got sides are equal, and you've got this side equal. Okay, opposite sides. So by side, they're equal, so corresponding parts are equal. Rectangle. This is, oh, up here, you guys, I put is. This should be if. If a parallelogram. No. A rhombus is, a rhombus is a parallelogram with all sides equal. Okay, here we're going to do a rectangle is a parallelogram with, notice, they're all going to be right angles, okay? A rectangle is a parallelogram with 4 right angles. Now what happens on this one, okay, you could look at this. These are not perpendicular unless only for rhombus are they perpendicular, the diagonals. On this rectangle, if you get a long skinny rectangle that's not a rhombus, the diagonals are not perpendicular, but the diagonals do have equal lengths, okay? The diagonals are equal lengths. So if a parallelogram is a rectangle, then the diagonals are congruent. They're equal length. Okay, now for a square, go back to what we said in the beginning. Okay, a rectangle, we could fill this in if you have enough room. A rectangle has these 5 theorems true. It also has 4 right angles, and these diagonals are equal length. Diagonals are congruent. Okay? A rhombus, all 5 theorems for all parallelograms, that's true because a rhombus is a parallelogram, and you have 4 congruent sides, and the diagonals are perpendicular to each other, and the diagonals bisect opposite angles. Okay, so you've got all this true for a rhombus, You've got all this true for a rectangle. When it comes to a square, when it comes to the square, you've got all 5 of these. You've got both of these for the rectangle, and you've got 3 of these for the rhombus. That's it, okay? So when you come down here for a square, write down all parallelograms, theorems are true, right? Everything about a parallelogram is true for a square. Everything true about a rectangle is true for a square. All rectangle theorems are true. And finally, because it's also a rhombus, all rhombus theorems are true. That's the gist of this lesson, okay? When you guys look at this down here, these can be tricky, so you're going to have to think. They're hard. You just have to think. It says for any rhombus, QRST. First thing I do is draw it, and it's a rhombus. Okay? So because it's a rhombus, I'm going to do this. And I know it's a parallelogram too, right? But that's all I know for sure. And it's a rhombus. Okay? And I've got QRST, start wherever you want. Just keep going in order once you name it. Don't jump around. Okay, it says angle Q and S. Q and S, are they equal? So decide, are they opposite angles? Are they consecutive angles? And it says angle Q and R. They're congruent. Can Q and R be true? Are they never, can they be congruent? Is it sometimes true that they're congruent? Could they never be congruent? Are they always congruent? That's what the question is. You're going to have to think. This one says the length from Q to R. The length from Q to R and the length from S to T. Is it sometimes? Are they equal? Never are they equal. Always are they equal. This one's a little tricky. Watch. This says Q to S. Q to S is here, and R to T. Are they equal to each other? Okay? These are talking, this one's talking about the diagonals. Okay? So each of those is an always, sometimes, or never. Okay. Flip it. Back page. Find the measure of each angle. Now this is a rhombus. Because it's a rhombus, I'm going to look at the rhombus theorems, okay? So in my rhombus theorems, and I'm going to look at my picture of my rhombus. Okay, here we go. I know that I've got right angles where they intersect, because it's a rhombus. So that means this will be a right angle. All of these are going to be right angles. Okay, here's why. If one is 90, 180 is a straight line, so that means this one's 90. Then I cover it up. Straight line is 180, so this has to be 90. Keep on going. So each of these is 90. You only have to mark one, but they're all 90. We know because it's a rhombus, all these sides are equal. We also know because it's a rhombus, the diagonals bisect each other. So that means this angle equals this angle, and this angle equals this angle. That will help me get started. Okay, this is 61 degrees. I'm going to redraw this triangle right here. Okay, I'm going to redraw that one. And I'm going to draw it right over here. Same exact triangle. Okay. Now, I know that this is 90 degrees. I'm told this is 61. The golden rule for a triangle is the sum of the interior angles is always 180. So you are going to add these up, get 180. That will give you this angle right here. Okay? Now, once you get that, well, let's just do it real quick. I'll do it with you. 90 plus 61 plus x is 180, right? 90 and 60, 151 plus x is 180. Go ahead and subtract it. You get x is 29. Okay? So this angle is 29. Now here's where you got to start filling everything in. So that means this one's 29, this angle, 29 degrees. This angle here, 29 degrees. This one up here would be 29, this would be 29. Because opposite angles bisect each other, go back to this picture here. Okay? I've got, this is 61, so this is 61. Right? That's 122. This whole thing's 122. This whole thing's 122. All four of these triangles are congruent to each other. So this is 61, this is 61, this is 61. All of these. Okay? And that'll help you with that. Okay, let's go to number 3. Find the measure of each numbered angle in rhombus DEFG. So again, it's a rhombus. This one's a little bit easier, okay? In this picture, if you look at this, okay, I'll put this back. This triangle is congruent to this triangle by side, side, side. Side, side, side. So these triangles are flipped over, okay? They're flipped. That's what makes this angle congruent to this angle. The two triangles are congruent by side, side, side. This is an isosceles triangle, so these base angles are equal here. These base angles, if you look at it, there's an isosceles triangle. Can you guys see the isosceles triangle? Okay, I've got these two sides are equal, so the two base angles are equal. And then if this triangle is congruent to that triangle, you got the same deal. Okay? So here's the hard part. You guys, these are hard. This angle here is 118 degrees. These two angles are the same because it's an isosceles triangles and base angles are equal. So when I do this, I know also the golden rule is 180. So x plus 118 equals 180. Subtract your 118, divide by 2, and you will get those angles. Okay, this one, another one. Find the measure of each angle in this rhombus. Okay, you're going back to, it looks like, same idea, right? You've got an isosceles triangle, because these two sides are equal, so the base angles are equal, right? So if this angle right here, 26 degrees, would have to be the same as this one here, okay? And you know that the diagonals of a rhombus are perpendicular to each other. Okay. This one, rectangle QRST. I'm going to make it long and skinny so it's more obvious. QRST. The length from Q to S is 5x minus 31. The length from R to T is 2x plus 11. In a rectangle, diagonals are equal length. They're congruent. That's a part equals part. So that means these two lengths are equal to each other. So you're going to write your equation, solve for x, and then find the lengths of the diagonals. So after you get what x is, write your equation, part equals part, solve for x, and then substitute back x in to find the length of the diagonals. Okay. Number 6. In this rectangle, w to y is 4x minus 15. X to z is 3x plus 8. This is exactly the same thing as number 5. Just the numbers have changed. Number 7, a quadrilateral has 4 congruent angles. Okay? Is it a parallelogram? Explain. Why did you say that? Yes or no, and then why? So this means a 4-sided polygon has 4 congruent angles. Think how much each angle would have to be, right? So, is it a parallelogram? A 4-sided polygon, a quadrilateral, has 2 consecutive right angles. If it's not a rectangle, can it still be a parallelogram? Explain your answer. I would draw it and try to figure it out. These are good thinkers. Good thinking problems. Will a diagonal of a rectangle ever divide the rectangle into 2 isosceles triangles? Okay, if it's a rectangle, so like here, if I have a rectangle and I draw the diagonal, is this triangle going to ever be an isosceles triangle? Is there a specific type of rectangle I can draw so that I do have 2 isosceles triangles? Again, they're good thinkers. Give it a try, see what you got. Good job.